Dear learners, in this video we will speak about stress, strain and Hooke's law. The stress, if a body is subjected to any external force, the material will create a resisting force inside the body. The resistance offered by the body against the deformation due to the application of load is called as stress. And mathematically, the stress is denoted as sigma is equal to applied load by cross-sectional area, and this is measured in Newton per millimeter square. There are some of types of stresses. This is normal stress. Normal stress, there are two kinds. One is called tensile stress and another one is called as compressive stress. If a load is pulling the material, then it is subjected to tensile stress. If a load is pushing the material, then it is subjected to compressive stress. Apart from these stresses, there are two more stresses. One is called as shear stress, another one is called as bearing stress. A normal stress, this is the example for a tensile stress. It acts along the axis of the material. So it is called as normal and it acts normal to the cross section of the material. So it is called as normal force. If a force pulls the material in the two sides, then it is called as tensile force. If a tensile force is acting on a material, it will develop a tensile stress and that is equal to mathematically that is equal to sigma is equal to P by area. And for example, the compressive stress, for one more time, one more thing, the compressive stress, if a compressive force is acting on a material and if it is pushing the material, then the stress created inside the material is called as compressive stress. The difference is shown in that the tensile stress is taken in the positive sign and the compressive stress is taken in the negative sign. When a sign convention for stress is required, it is customary to define tensile stress as positive and compressive stress as negative. And apart from that, there is one more stress is called as shear stress. The force, if the force acts tangentially to the surface of the material and it is parallel to the axis of the material, then the stress created in the material is called as shear stress. Mathematically, it is denoted as tau is equal to shearing force by shearing area. And one more stress is called as bearing stress. A localized compressive stress at the surface of contact between two members of a machine part that are relatively at rest is known as bearing stress or crossing stress. So this is acting on the bolts. And mathematically bending stress is equal to load by area. And area is the thickness of the plate to the diameter of the bolt. So you can find the bearing stress. Strain. When speaking about strain, strain is the ratio of change in dimension of the body to the original dimension. Something, if a force is acting on a material, the material will go for elongation. That is deformation. It may be in the positive direction or it may be in the negative direction. So strain is a measure of change in dimension. I mean the deformation happening in the material to its original dimension. That is called as strain. There are some types of strains. One is called as linear strain, and that linear strain is subdivided into tensile strain and compressive strain. And apart from that, there are lateral strain, shear strain, and volumetric strain. When coming for this linear strain, if a force is acting axially to the material, there is a deformation taking place in the material. That is called as elongation in the material. So this del L is called as change in length and L is the original length. If we go for a tensile strain, epsilon is equal to del L by L. So when we go for a compressive strain, what we have spoken in the compressive stress, if the compressive force is acting on the material, then the material will go for a for a compression, so that the change in length is reduction. So change in length by original length, that is del L by L. So this is the compressive strain. And when you go for a lateral strain, these tensile strain and compressive strain acts along the axis of the along the longitudinal axis of the material. If it is pulled, there is a strain in the lateral direction which decreases the cross section of the material, and that strain is called as lateral strain. And when you go for a shear strain, if the force is acting on the surface of the material, it undergoes a shear strain. When you go for a volumetric strain, then epsilon V is equal to del V by V. Obviously, the volume must be equal. The volume is constant. If a change is happening in any one direction, the change will be the if it is in the elongation, if it produces elongation in the other two dimensions, there will be a decrement in the cross section. So the volumetric strain will be denoted as epsilon V is equal to del V by V. And there is one more criteria. There is one more concept that is called as Poisson's ratio. Poisson's ratio is the ratio of the lateral strain to the linear strain. Lateral strain is happening in the lateral axis and linear strain is happening in the longitudinal axis. This is the Poisson's ratio. And we come for Hooke's law. When a material is loaded within its elastic limit, a material is having an elastic limit. Beyond that elastic limit, it permanently deforms. If a material is loaded within elastic limit, if the force is removed, then the material will gain its uh, original dimensions. So original shape. So stress is within the elastic limit. The stress is directly proportional to the strain, and that is called as Hooke's law. Hooke's law is equal to stress by strain is equal to constant, and this is the Young's modulus. E is called as Young's modulus, and it is a concept of proportionality called as Young's modulus. And modulus of elasticity E is equal to linear stress by linear strain. Then factor of safety FOS is equal to ultimate or yield stress, working or allowable or design stress. I hope everyone has understand what is stress, strain and Hooke's law. Thanks for watching this video.